So when we talk about auto-oxidation reaction, so auto-oxidation reaction means that reaction where oxygen, which is already present in our atmosphere, that participates, right? To those reaction where
जी मैम,
oxygen
ये सब
exists in our atmosphere participates, and then finally the reaction takes place. And finally the reaction takes place, then that is called auto-oxidation reaction. I think we have already discussed this point in our previous class, right? How singlet oxygen convert into doublet triplet oxygen, right? And you know about singlet and triplet also. Triplet is more reactive compared to singlet, right? And it is more stable state also, we have already discussed. Now the problem related auto oxidation I already told, right? Because of auto oxidation in our atmosphere, right, there is a problem which is called corrosion, right? The corrosion is auto oxidation process, right? So if oxygen directly interact with material, right, if oxygen directly interact with material like metal, right, so then they rusted that metal, and that is actually auto oxidation process where Fe convert into Fe2 plus or Fe3 plus, right? So that process is auto oxidant. That is example of auto oxidation, right? Now food is spoiling, you know, food is spoil, right? If long time, if we put food for long time, then you know this mechanism we had already discussed. This is basic mechanism of free radical where start from initiation, right? Initiation of peroxide, then they convert into free radical, then they convert into free radical, right? Normally this reaction takes place in presence of sunlight, right? तो सनलाइट की प्रेजेंस में ही नॉर्मली फोटो ऑटो ऑक्सीडेशन रिएक्शन होती है, हमने डिस्कस किया था. वंस दे कन्वर्ट इनटू फ्री रेडिकल, देन दे कैन एब्स्ट्रैक्ट हाइड्रोजन. हाइड्रोजन का एब्स्ट्रैक्शन हो सकता है, हाइड्रोजन एब्स्ट्रैक्शन होगा, देन दे कन्वर्ट इनटू फ्री रेडिकल, राइट? Once they convert into hydrocarbon free radical, then hydrocarbon free radical can react with oxygen, convert into this types of ion, right? And then follow reaction, and then the termination reaction, right? So we have already discussed these points related to free radical reaction, right? Different types of. So this is, you can see this is the you can see this is auto oxidation, right? So if auto oxidation of any material, right, or any food product, then you can see here, right? This is our apple, right? After a long time you can see that apple like this, right? Why? Because of auto oxidation. It is because of auto oxidation. So auto oxidation, this is region behind why the apple is slowly spoiled. What is region behind that? So the region behind that is auto oxidation of that apple, right? So if you cut apple, then after some time or after 1 day or 2 day, then that look like this, and slowly they completely damage, right? And that process is called auto oxidation. You can see here your bread also, right? You know, there is also expiry date of bread. Why expiry date of bread? What is reason behind that? Because after some time there also oxidation. You can see here, right? The fungus start generate on bread, right? Why? Because of auto oxidation. So this is auto oxidation process. Normally the process takes place in presence of sunlight, right? And the oxidation may be catalyzed by fungus, they may be catalyzed by bacteria, they may be catalyzed by some other catalyzing agent also. They may be catalyzed by some other catalyzing agent also, right? So you can see this types of point, right? So this is important point. Now after that you can see next one, auto oxidation. This is important process, right? And the process pass through, or these process normally takes place in presence of free radical, right? So normally these are free radical oxidation process. Now after that, next point of discussion related to free radical aromatic mechanism, free radical aromatic substitution mechanism. Now if we talk about free radical aromatic substitution mechanism, it means we are talking about aromatic compound, we are talking about benzene, right? So how benzene give aromatic nucleo free radical aromatic substitution reaction? So same like electrophilic or nucleophilic aromatic substitution reaction, free radical aromatic substitution reaction also. So free radical, because same like a nucleophile or electrophile, it is also one of the important intermediate, right? So almost the mechanism is same, right? Now what is difference between nucleophilic aromatic substitution reaction, electrophilic or free radical? How do you differentiate that? The first point, if we discuss about effect of different types of factor, how affect electrophilic aromatic free radical nucleophilic substitution reaction. So you can say first point, right? How solvent affect free radical nucleophilic substitution reaction? How free radical nucleophilic substitution reaction is affected by free radical? So you can see here, right? First point, uh, the effect of a solvent is very small, right? So you can say that very little effect of solvent, very little effect of solvent, right? So solvent almost not affect our nucleophilic aromatic substitution reaction normally, right? So it means the rate of reaction in gaseous phase or the rate of reaction in solvent phase approximately same, like तो गैसेस फेज में जो रेट ऑफ फ्री रेडिकल सब्स्टिट्यूशन रिएक्शन होती है वही आपकी सॉल्वेंट में भी होती है, बहुत ज्यादा अफेक्ट नहीं होता है. In a very few cases, right? In very few cases, if we talk about chlorination, you people already know chlorination reaction, right? If chlorine work like a attacking reagent, then the reaction is very fast, right? Then the reaction is very fast, right? You know, selectivity and reactivity. Chlorine is very famous for reactivity, right? So when chlorination takes place, right? When chlorination takes place on 2,3-dimethyl butane, then this types of product form. You can see if aliphatic solvent, if we use aliphatic solvent, then 60:40, and if aromatic, then 10:90, right? So if we use aromatic solvent, then this is the ratio of to product, and if aliphatic, then this is the ratio, right? This is the ratio and this is the ratio, right? It means aliphatic compound, chlorination of aliphatic compound is highly affected by types of solvent, right? So types of solvent is very important in aliphatic free radical substitution reaction, but it is not much more useful for aromatic free radical substitution reaction, right? So it is important, right? So unlike nucleophilic or electrophilic substitution reaction, right, solvent is very little affect our free radical nucleophilic free radical substitution reaction, right, or free radical mechanism. So this is important point. Now after that, you can see next important point, right? If we talk about electron withdrawing group or electron donating group, right, or if we talk about some group attached at benzene ring, then what about their effect, right? So very small effect, right? Same like solvent, right? There is very small effect, but if we compare, right, so both electron withdrawing group and electron donating group both stabilize your benzene ring, because you know free radical, it means that is a neutral intermediate, right? तो फ्री रेडिकल क्या होता है, न्यूट्रल इंटरमीडिएट होता है, इसलिए इलेक्ट्रॉन विड्रॉइंग हो चाहे इलेक्ट्रॉन डोनेटिंग हो, दोनों के दोनों फ्री रेडिकल को क्या करते हैं, स्टेबलाइज करते हैं, राइट? इट मींस नॉट मच मोर अफेक्ट, or you can, it is not possible we can compare that much more, right? Effect is very small. Next important thing, if we compare, right, तो कौन किससे डोमिनेट होगा, इलेक्ट्रॉन विड्रॉइंग ग्रुप, इलेक्ट्रॉन विड्रॉइंग ग्रुप जो होते हैं दैट इज डोमिनेंट ओवर इलेक्ट्रॉन डोनेटिंग ग्रुप, राइट? इलेक्ट्रॉन विड्रॉइंग ग्रुप जो होते हैं वो इलेक्ट्रॉन डोनेटिंग ग्रुप से ज्यादा डोमिनेंट होते हैं. इट इज आल्सो इंपॉर्टेंट पॉइंट, राइट? मेटा इज नॉट अफेक्टेड, राइट? तो इफ यू वांट एक्टिवेट योर फ्री रेडिकल, देन इलेक्ट्रॉन विड्रॉइंग ग्रुप शुड बी एट द पोजीशन ऑफ ऑर्थो और पैरा पोजीशन पे होने चाहिए, राइट? तो ऑर्थो और पैरा पोजीशन ज्यादा एक्टिवेटेड होती है एज कंपेयर टू मेटा पोजीशन, राइट? तो मेटा इज नॉट effective position or not effective position, you can say, right? But ortho and para, they are effective position, right? If you compare the ortho better than para, right? But the point is that there should be no steric hindrance problem. If there is some steric hindrance problem, agar wahan pe kuch steric hindrance problem hogi, so then meta is better, sorry, para is better, right? So if you compare which is better position, so ortho is better position compared to para, right? But the point is there should be no steric hindrance problem, right? And meta is not effective position, right? So if you compare electron withdrawing group or electron donating group, if you compare electron withdrawing group or electron donating group, so electron withdrawing group dominant over electron donating group, right? तो इलेक्ट्रॉन जो विड्रॉइंग ग्रुप होता है वो डोमिनेट होता है ओवर इलेक्ट्रॉन डोनेटिंग ग्रुप, राइट? तो इस तरह से आप बात कर सकते हो, राइट? Now after that, next point about effect, right? So you can see attacking group, chlorination is you know, chlorination, it means that is much more reactive compared to bromine, right? Chlorine is much more reactive, same here also, right? But that is less selective, we people already know. right? Bromination is so selective, right, in free radical aromatic substitution reaction also. Same like in case of nucleophilic and electrophilic, same like in case of nucleophilic and electrophilic also, right? So there is no much more difference between the mechanism of nucleophilic aromatic substitution reaction or electrophilic, and also you can see that free radical nucleophilic substitution reaction, almost same, right? There is a little bit difference about the factor effect. Now you can see same their mechanism also. You can see here if you have aryl radical, right, AR free radical, if benzene with free radical, and they react with next benzene molecule. If they react with next benzene molecule, then what about their mechanism? You can see their mechanism, right? Here, first they convert into a resonance structure, right? You can see this types of compound. If AR free radical attack at benzene, right? So then the bond will break, sigma bond convert into, sorry, this pi bond convert into sigma bond, and then they convert into this types of radical, and that radical give their resonance structure, first ortho, then para, and then ortho position. This is their resonance hybrid structure. This is their resonance hybrid structure. It means almost same like nucleophilic or electrophilic aromatic substitution reaction. It means in first step, right, different types of resonance form, different types of resonance form, right? So first step same like first in case of nucleophilic or electrophilic aromatic substitution reaction, right? Now after that you can see so many types of product form, right? You can see here so many types of product formed after free radical nucleophilic substitution reaction, right? So there are so many types of coupling reaction. You can see here, right? If suppose that this is our intermediate, free radical intermediate, if suppose that this is our free radical intermediate, if AR with free radical attack, right? So there is some time ipso attack also, right? Removal of hydrogen from same position where AR come, right? So this is aryl free radical. So if two molecule of aryl free radical react, then there is a coupling reaction and they convert into this types of product, right? तो फिर वो इस टाइप के प्रोडक्ट में कन्वर्ट हो जाएंगे, right? ऑर्थो पोजिशन, राइट, जहां पे क्योंकि ऑर्थो पोजिशन ही एक्टिव पोजिशन होगी तो ऑर्थो पोजिशन से वो एक दूसरे से अटैक कर देंगे, राइट? नाउ सेकंड वन यू कैन सी इफ वी टॉक अबाउट टर्मिनेशन स्टेप, इट इज एक्चुअली अबाउट टर्मिनेशन स्टेप, राइट? लास्ट स्टेप जो होता है जिसे आप टर्मिनेशन स्टेप कहते हैं तो वही है. समटाइम देयर इज कपलिंग of free radical. You can see there sometime there is coupling of free radical, sometime there is a disproportion reaction, and after disproportion, you know, right, one take hydrogen and other give hydrogen, right? तो दोनों में से एक हाइड्रोजन को देगा और दूसरा हाइड्रोजन को ले लेगा, right? So if one take hydrogen, then they convert into this types of compound, unsaturated cyclic compound, right? They convert into unsaturated cyclic compound. And if one give hydrogen, then they convert into a aromatic compound, right? And diaryl, they convert into diaryl, right? So after disproportion, one diaryl form and second cyclic alkene form, right? So this is reaction. This is important one termination reaction also, and this is called disproportion, right? तो जब disproportion होता है तो दो में से एक क्या करता है, हाइड्रोजन को देता है और दूसरा हाइड्रोजन को लेता है. तो वही यहाँ भी हो रहा है, एक हाइड्रोजन को दे रहा है और दूसरा हाइड्रोजन को क्या कर रहा है, ले रहा है, राइट? तो दिस इज द रिएक्शन. नाउ आफ्टर दैट यू कैन सी इफ in the end of the reaction, right, if there is suppose that R minus, if there is R minus, so R minus can take, right, or R free radical can take H, right, and then they convert into RH, right, and then they convert into diaryl, right? So these are three important reactions. If there is a impurity, this is normally takes place in presence of impurity. अगर impurity में कोई alkyl free radical है, so that alkyl free radical react with H radical and convert into RH, right, and then diaryl will form, right? डिस्प्रोपोर्शन में मैंने कह दिया साइक्लिक एल्कीन बनेगा, साइक्लिक एल्कीन डाइईन बनेगा, साइक्लिक डाइईन बनेगा एंड डाइएराइल अलग हो जाएगा, राइट? एंड कपलिंग रिएक्शन में आप देखिए, इन कपलिंग रिएक्शन यू कैन सी दिस टाइप्स ऑफ प्रोडक्ट विल फॉर्म, राइट? तो इस टाइप्स का प्रोडक्ट क्या होगा, बन जाएगा, राइट? तो दीज आर सम इंपॉर्टेंट प्रोडक्ट व्हिच फॉर्म्ड आफ्टर free radical aromatic free radical aromatic substitution reaction, right? तो इस टाइप के प्रोडक्ट इसमें बनते हैं, right? Now after that you can see next one, SN1 reaction, right? If we talk about SN1 reaction, right, it means first order free radical substitution reaction, right? So it is similar to SN1. It is similar to SN1, right? So free radical, first order free radical substitution reaction. SF1 भी कह सकते हैं आप. You can write their name SF1, right? So very simple reaction. If you have chlorobenzene, suppose that, right? and in presence of H nu, if they lose free radical of chlorine, right, if they lose a free radical of chlorine, then they convert into aryl free radical, then they convert into aryl free radical. And now this aryl free radical when react with, right, any free radical or any attacking free radical, then they convert into final product, right, then they convert into final product. So this is first order nucleophilic, this is first order free radical substitution reaction. Why it is first order free radical substitution reaction? Because of in first step only one reactant participate, because of in first step only one reactant participate, right. तो पहले स्टेप में केवल एक ही reactant participate कर रहा है, which is slow step, which is rate determination step. This is reason why this free radical is formed. This is reason why this free radical form in first step, right. And after that your attacking group or your attacking free radical attack, and they convert into this types of product, they convert into this types of product, right. So this is the reaction you can see here. Now after that, next one, if we talk about neighboring group participation mechanism, right, तो neighboring group participation mechanism के बारे में तो sorry, ये है SNI mechanism, right, internal nucleophilic aromatic substitution reaction, right. So you know after this reaction retention of configuration, इस reaction के बाद क्या होता है, retention of configuration होता है, right. After this reaction retention of configuration, right. So if optical active compound like this types of optical active compound if react with thionyl chloride, you people already know, I have already discussed SNI mechanism, right, कि SNI mechanism में क्या होता है, thionyl chloride जो होता है वो आपके optical active compound से react करता है, and then you know this SOCl attack at this part, right, and then HCl will remove out and they convert into this types of intermediate, then this intermediate convert into ion pair, और उसके बाद ये जो intermediate होता है किस में convert होता है, ion pair में convert होता है, right, because you know this bond will break, right, ये वाला bond break हो जाता है, right, O पे माइनस चार्ज आ जाता है और C पे भी क्या आ जाता है, प्लस चार्ज आ जाता है, right. So then they convert into ion pair. After that this Cl attack at this position, ये Cl जो होता है इस position पे attack करता है, right, and then SO2 sulfur dioxide will remove out, right, and then sulfur dioxide will remove out, right, during this reaction sulfur dioxide will remove out, right, and this is called retention of configuration because in this reaction, right, because in this reaction SO2 Cl attack from right hand side and Cl minus also attack from same side, right. तो जो आपका Cl minus अटैक करता है वो उसी साइड से अटैक करता है जिस साइड पे आपका SO2Cl पहले से है, right. So this is called retention of configuration. This is called retention of configuration, right. तो internal क्यों कहते हैं, because क्या होता है अंदर ये जो मॉलिक्यूल है इसके अंदर ही जो आपका इंटरमीडिएट है उसके अंदर ही सब्स्टिट्यूशन रिएक्शन होती है, तो सो दिस इज कॉल्ड इंटरनल न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन, राइट. तो अब क्या होता है, इफ द रिएक्शन टेक्स प्लेस इन प्रेजेंस ऑफ pyridine, अगर ये रिएक्शन pyridine की प्रेजेंस में होती है, राइट, इफ द रिएक्शन टेक्स प्लेस इन प्रेजेंस ऑफ pyridine, देन दे कैन फॉलो बोथ मैकेनिज्म. फिर वो क्या करता है, दोनों मैकेनिज्म को फॉलो करता है, SNI मैकेनिज्म को भी और SFI मैकेनिज्म को भी, right. So they can follow free radical mechanism also, and they can follow nucleophilic SNI mechanism also, right. And then the product show Walden inversion, right. It means then inversion of configuration hota hai. If R then S, then they convert into S, and if S then they convert into R, right. तो यहाँ पे क्या होगा, R R में convert होगा, S S में convert होगा by SNI mechanism, R convert into R and S convert into S, because here retention of configuration. But the reaction, if the same reaction takes place in presence of pyridine, जो एक बेस होता है, pyridine की प्रेजेंस में जब ये रिएक्शन होती है तो फिर वो न्यूक्लियोफिलिक न्यूक्लियोफिलिक और या फ्री रेडिकल दोनों मैकेनिज्म को फॉलो कर सकता है, एंड देन देयर इज ए वॉल्डन इन्वर्जन. फिर वहां पे क्या होता है, वॉल्डन इन्वर्जन होता है. इट मींस R form convert into S form and S form convert into R form. You can see here, right, this is a compound, this is your intermediate which is formed, right, ये intermediate बनेगा. Now this react with pyridine, अगर वो किससे, pyridine से रिएक्शन करता है, if they react with pyridine, right, and HCl और pyridine से अगर वो रिएक्शन करता है, तो then you can see HCl और pyridine से जब रिएक्शन होती है तो then Cl attack at this position. Cl जो होता है ये या तो Cl माइनस या तो Cl रेडिकल, वो कहां पे अटैक करता है, इस पोजीशन पे अटैक करता है, राइट, बैक साइड. right? Not from front side, that attack from back side, वो back side से attack करता है, sometimes Cl minus, sometimes Cl radical, right? And then they convert into this types of intermediate. उसके बाद वो इस type के intermediate में convert. If free radical, right? So then you can see here free radical, and if positive charge, then if nucleophilic reaction, then their positive charge, right? तो ये फिर यहाँ पे attack कर देते हैं, and then finally the product form like this, right? And this is the product is inversion of configuration based product, right? ये जो product बनता है, ये inversion of configuration basis product बनता है. क्या बनता है? Inversion of configuration basis product बनता है. Pyridine as it is separate हो जाता है, because that work like a catalyst, right? क्योंकि वो catalyst की तरह work कर रहा है, तो इसलिए वो as it is क्या हो जाता है? Remove out हो जाता है. Sulfur dioxide, you know, during SNI mechanism, sulfur dioxide always remove. तो कहने का अर्थ ये है, if the reaction proceed in presence of pyridine, right, then they can follow both nucleophilic internal nucleophilic substitution mechanism or internal free radical substitution mechanism, and then the final product is show inversion of configuration. It means R converting to S and S converting to R, right? So this is about mechanism. This is about SNI mechanism, right? Same like SNI mechanism, right? But little bit difference. There is a possibility of inversion of configuration also. There is a possibility of inversion of configuration also, right? Now after that, next one, this is also one of the important reaction, right? That there is important catalyst, that is copper ion, right? So coupling reaction of alkyne, right? So if a coupling reaction of alkyne, अगर alkyne की coupling reactions होती है, alkyne they may be acetylene, right? Or they may be a derivative of acetylene. Acetylene के derivative होते हैं. रिएक्शन सेम इन प्रेजेंस ऑफ pyridine बेस. ये रिएक्शन भी क्या होती है? pyridine बेस की प्रेजेंस में होती है. जब pyridine बेस की प्रेजेंस में होती है, तो देन दे फॉलो फ्री रेडिकल मैकेनिज्म. फिर वो क्या करता है? फ्री रेडिकल मैकेनिज्म को फॉलो करता है, राइट? एंड द कैटलिस्ट हियर, कैटलिस्ट रिक्वायर्ड दे आर copper ion, right? तो copper ion as a catalyst यहाँ पे वर्क करता है. तो you can see here very simple, if they may be acetylene or derivative of acetylene, CH ट्रिपल बॉन्ड CH हो सकता है, या CH3 C ट्रिपल बॉन्ड CH3 C ट्रिपल बॉन्ड क्या हो सकता है? H हो सकता है, राइट? तो इस तरह के कंपाउंड हो सकते हैं. If they react with pyridine, right? This is a base, actually it is a pyridine, right? If they react with pyridine, तो pyridine क्या करेगा? H को ले लेगा, right? H minus को ले, H plus को ले लेगा, right? And then here negative charge, then they convert into negative charge, right? They convert into carbanion, right? Now this carbanion react with copper ion, right? Copper in cupric form. Copper किसमें? Cupric form, Cu2 plus, right? And then you can see here Cu2 plus convert into Cu plus, right? And during that process, you know, because oxidation number change from 2 to 1, because oxidation number जो है 2 से क्या हो जाती है? 1 हो जाती है. It means they absorb 1 electron. It means they absorb 1 electron from this negative charge. And you know, when copper absorb 1 electron, then they convert into you can see Cu2 plus to Cu, and then negative charge convert into free radical. जो negative charge होता है वो free radical में convert हो जाता है. Free radical can convert into negative charge. Free radical negative charge में convert हो सकता है when Cu plus convert into Cu2 plus, right? Copper जब प्लस से कॉपर 2 प्लस में कन्वर्ट होता है, तो Cu फ्री रेडिकल कन्वर्ट इनटू Cu नेगेटिव, सॉरी एल्काइन, ठीक है? एल्काइन फ्री रेडिकल कन्वर्ट इनटू एल्काइन carbanion, right? So yeah, this is the reaction, very simple reaction, you can see, right? So this is the mechanism, right? In first step, your pyridine, right, absorb H plus, your pyridine absorb H plus, then they convert into this carbanion, right? Now this carbanion react with Cu, you can see Cu2 plus, right? And then Cu2 plus convert into Cu1, because negative charge give their 1 electron, convert into free radical, right? And after that, two free radical of alkyne can interact and react and then convert into this types of dimer, right? Then they convert into this types of dimer, and this is called coupling reaction of alkyne. This is called coupling reaction of alkyne, right? तो इसे क्या कहते हैं आप? Coupling reaction of alkyne. Alkyne की coupling reaction कहते हैं. So this is also one of the important reaction and part of the free radical mechanism, right? तो ये भी free radical mechanism का part है. Now after that our discussion, right? Now after that our discussion, coupling reaction of diazonium salt, right? Now after that our reaction about coupling reaction of diazonium salt. तो डायजोनियम साल्ट का कपलिंग रिएक्शन, नाउ आवर डिस्कशन ऑन कपलिंग रिएक्शन ऑफ डायजोनियम साल्ट, राइट? तो गेम्बर्ग backmann reaction, this is also called Gomberg backmann reaction because these two scientists give this reaction, right? So what about this reaction, formation of diaryl compound? This is the reaction for formation of diaryl compound. Diaryl compound की formation के लिए ये reaction होती है. This is the reaction for formation of diaryl compound. ठीक है? तो diaryl compound कैसे बनता है, किस तरह से बनता है, right? तो you can see here, right? तो यहाँ पे क्या है, बेंजीन डाइएजोनियम क्लोराइड और हैलाइड, राइट? व्हेन बेंजीन डाइएजोनियम क्लोराइड और बेंजीन डाइएजोनियम हैलाइड रिएक्ट विद बेंजीन, रिएक्ट विद एराइल कंपाउंड, रिएक्ट विद बेंजीन और रिएक्ट विद एराइल कंपाउंड, जब वो एराइल कंपाउंड से या बेंजीन से रिएक्ट करता है इन प्रेजेंस ऑफ स्ट्रॉन्ग बेस, इन बेसिक कंडीशन OH माइनस की प्रेजेंस में, राइट? OH माइनस की प्रेजेंस में जब योर बेंजीन डाइएजोनियम क्लोराइड और हैलाइड रिएक्ट विद बेंजीन, right, or derivatives of benzene, then they convert into diaryl, and this is also, you can say that this is also coupling reaction, right? And because diazonium salt participate in this reaction, so it is called diazonium salt based coupling reaction, right? And Gomberg and backmann give this reaction, so this is called Gomberg backmann reaction, right? And this condition, basic condition, is also called Gomberg backmann condition, right? And after that diaryl will form. Now what about the mechanism of this reaction? What about the mechanism of this reaction? So this, in first step, actually this benzene diazonium halide, right? This benzene diazonium halide when react with OH minus, right? So then this X minus replaced by OH minus. This is like a nucleophilic substitution reaction, right? So in first step, this ARN2 plus X minus react with OH minus, and then X minus replaced by OH minus, right? So X minus जो होता है वो OH minus से replace हो जाता है, and then that hydroxy compound react with other hydroxy compound, and then they convert into anhydride, and then that anhydride react with your benzene or aromatic derivative compound, right? And then they convert into this product. You can see mechanism of this reaction. You can see now what about the mechanism of this reaction, right? Very important thing, anhydride formed during this process. This is important point. This is an important point. Anhydride formed during this reaction. इस रिएक्शन में एनहाइड्राइड बनता है, ये इसका एक बहुत इंपॉर्टेंट स्टेप है, राइट? तो व्हेन बेंजीन डायजोनियम हैलाइड, व्हेन बेंजीन डायजोनियम हैलाइड react with OH minus, when benzene diazonium halide react with OH minus, right? तो जब बेंजीन डायजोनियम हैलाइड क्या होता है, OH minus से रिएक्शन करता है, तो then there is a substitution reaction, then there is a substitution reaction. फिर वहां पे क्या होती है, एक substitution reaction होती है, फिर वहां पे क्या होती है, एक substitution reaction होती है, और जब वहां पे एक substitution reaction होती है, then they convert into dihydroxy compound. फिर वो किस में कन्वर्ट हो जाता है, डाइहाइड्रोक्सी कंपाउंड में, और इस तरह से OH वाले कंपाउंड में कन्वर्ट हो जाता है, राइट? यू कैन सी डाइएजो हाइड्रोक्सी कंपाउंड, डाइएजो हाइड्रोक्सी कंपाउंड में कन्वर्ट हो जाता है, राइट? एंड देन वंस अगेन दिस कंपाउंड, सेम कंपाउंड, दो मॉलिक्यूल क्या होंगे, एक दूसरे से रिएक्ट होंगे, राइट? एंड देन देयर इज ए condensation reaction, right? H2O will remove out, right? OH इसका और H इसका, H2O will remove out, and they convert into this types of anhydride. ये क्या हो जाएगा, इस टाइप के एनहाइड्राइड में कन्वर्ट हो जाएगा, ये क्या हो जाएगा, इस टाइप के एनहाइड्राइड में कन्वर्ट हो जाएगा. नाउ द एनहाइड्राइड इज वेरी अनस्टेबल, राइट? अब ये एनहाइड्राइड क्या होता है, जो डायजोनियम जो कंपाउंड है उसका एनहाइड्राइड, इट इज हाईली अनस्टेबल, एंड देन दे कन्वर्ट इनटू एराइल रेडिकल, nitrogen gas, and this types of, you can see, radical, right? So then nitrogen gas will remove out. Now this aryl radical, अब ये जो aryl radical बनता है, now this aryl radical react with second molecule of benzene. Aryl radical जो होता है वो second molecule of benzene से react करता है, right? And when they react with second molecule of benzene, right, जब वो second molecule benzene से react करता है, तो then ipso attack होगा, right? जहां से हाइड्रोजन निकलता है वहीं पे AR अटैक करता है, right? And then, right, at the end H free radical will remove out and your diaryl compound also produce, right? तो आपका diaryl compound बन जाएगा, हाइड्रोजन फ्री रेडिकल इस रिएक्शन में रिमूव हो जाएगा. Now this hydrogen free radical react with this compound and they convert into ARN2OH. राइट। तो ArN2OH एज इट इज आपका फाइनल क्या हो जाएगा, प्रोड्यूस हो जाएगा, राइट। तो दिस इज ऑल्सो वन ऑफ द इंपॉर्टेंट मैकेनिज्म, दिस इज ऑल्सो वन ऑफ द इंपॉर्टेंट मैकेनिज्म, राइट। तो ये भी एक इंपॉर्टेंट मैकेनिज्म है, राइट। And during this mechanism anhydride will form, right? During this reaction anhydride will form and OH is required for this mechanism, right? इस mechanism के लिए diazonium salt की जो ये mechanism होती है, इसकी coupling reaction के लिए आपको OH minus की क्या होती है, basically क्या होती है, requirement होती है, right? So this is also one of the important free radical aromatic nucleophilics, free radical aromatic substitution reaction, right? Now उसके बाद neighboring group participation mechanism, you people already know about neighboring group participation mechanism, right? तो neighboring group participation mechanism के बारे में पहले भी मैंने आपसे कई बार डिस्कस किया था, right? It's a very famous reaction, you can see AR, if suppose that this is your neighboring group, right? So in presence of neighboring group the reaction goes very fast, right? ये जो reaction होती है, right, nucleophilic substitution reaction होती है, बहुत fast हो जाती है. And what is basic requirement for neighboring group? There should be at least one lone pair of electron. उसके पास कम से कम क्या होने चाहिए, एक lone pair of electron होना चाहिए, right? And you can see here X will remove out, right? X minus will remove out, right? And if suppose that nucleophilic substitution neighboring group nucleophilic substitution reaction, then X minus will remove out. X minus क्या हो जाएगा, remove out हो जाएगा, right? And then Cl will come here, right? Cl will come here, Cl इस position पे आ जाएगा, you can see Cl will come at this position, right? And they convert into this types of bridge, right? और cyclic intermediate, right? इस type के cyclic intermediate में convert हो जाएगा. अगर ये X नेगेटिव जाएगा तो यहाँ पे क्या जाएगा, पॉजिटिव चार्ज आ जाएगा. और इफ सपोज दैट X मूव एज ए फ्री रेडिकल, अगर X एक फ्री रेडिकल की फॉर्म में जाएगा तो देन फ्री रेडिकल कम एट दिस पोजीशन, राइट. तो देन फ्री रेडिकल कम एट दिस पोजीशन, तो ऑलमोस्ट सेम ही मैकेनिज्म है, राइट. एंड देन यू नो न्यूक्लियोफाइल कम फ्रॉम बैक साइड, न्यूक्लियोफाइल क्या होगा, नीचे की साइड से फिर क्या करेगा, अटैक करेगा, राइट. तो हियर क्या होता है, इंट्रा एंड इंटर, तो ये क्या होता है, इंट्रा मॉलिक्यूलर, राइट, ये होता है इंट्रामॉलिक्यूलर रिएक्शन और ये होता है इंटरमॉलिक्यूलर रिएक्शन, राइट. तो NU कम फ्रॉम दिस साइड, NU क्या होगा, इस साइड से आएगा, राइट, नीचे की साइड से आएगा. एंड देन दे गिव रिटेंशन ऑफ कॉन्फिगरेशन, फिर वो क्या करेगा, रिटेंशन ऑफ कॉन्फिगरेशन को देगा, राइट. तो दिस इज द रिएक्शन न्यूक्लियोफिलिक एरोमेटिक सब्स्टिट्यूशन रिएक्शन, वेरी फेमस रिएक्शन, बहुत फेमस रिएक्शन होती है न्यूक्लियोफिलिक एरोमेटिक सब्स्टिट्यूशन रिएक्शन, राइट. अब इसमें सॉरी नेबरिंग ग्रुप पार्टिसिपेशन मैकेनिज्म, राइट, इसमें इंट्रा और इंटर दो स्टेप्स होते हैं फॉर कंप्लीशन ऑफ रिएक्शन, राइट. SN2 मैकेनिज्म जो होता है, राइट, SN2 जो मैकेनिज्म होता है उसको ही ये क्या करता है, फॉलो करता है, राइट. तो फर्स्ट इस तरह से ये निकलेगा और देन ये इस तरह से कन्वर्ट हो जाए, राइट. तो दिस इज द मैकेनिज्म व्हिच वी हैड ऑलरेडी डिस्कस, पहले भी हमने ये डिस्कस किया था. Now, if we talk about bromination, अगर हम bromination की बात करते हैं तो they also follow neighboring group mechanism, right? तो neighboring group participation by bridgehead free radical, right? तो अगर bridgehead free radical बनता है तो भी ये process होती है. And if neighboring group bromination, then 84 to 94% substituted product will form, right? तो 94 से 84 to 9, it means the production is very very high, right? When the reaction takes place in presence of free radical. तो free radical की presence में जब neighboring group participation mechanism होती है तो then bridgehead free radical बनता है. एक तो सबसे important point क्या है, bridgehead free radical बनता है and the production of reaction is very very high. और उसके बाद जो production होती है reaction की वो बहुत ज्यादा high होती है, right. तो within 1 minute the link will expire and we will rejoin at same link, right.